I will quickly introduce Bill McKechnie. Bill has a BSc Honours in Geology from Aberdeen University, and we would have heard, or you would have heard his accent, which kind of is a giveaway. He's an extremely highly experienced exploration and project development geologist with more than 45 years experience in the international mining and metals industry at executive level, strategic and operational level. Bill's also had a particularly long and successful career in diamonds, most of it with De Beers. He was, for example, part of the original team that discovered the Phoenicia diamond mine in the northern part of Limpopo many years ago. So thanks, Bill. Thanks for making time to listen to all these talks, and we look forward to both your presentation and wrap up.
Thanks, John. Okay, I'm not on mute. Good. Okay, thanks very much for the invitation to present here. It's been an interesting 2 weeks. I'm sure it's been the case for everyone. This course covers an immense scope in terms of the industry that we're involved in, a very broad field. A lot of the information that we've been discussing, of course, is really developed scientifically over the last 50 to 60 years, especially those parts that relate to diamond exploration, which is my main field of interest. Having heard so much in the last 2 weeks, it's obviously difficult to avoid duplication, but I've done as much as I can to try and avoid that, and hopefully you'll agree. But I'd also just like to point out that next year is the 50th anniversary of the first International Kimberlite Conference that was held in Cape Town in 1973. So many of the things that we've listened to this week have really developed out of the lines of research that were put in place at that time, and all the new developments have taken place because of the tremendous exploration success that the industry has enjoyed over that period, as well as all the scientific input that we've seen and has been explained by Herman and others. Okay, I'm going to look at, in this presentation, I'm going to give an update on diamond exploration budgets as reported by S&P Global that report annually on these things as part of their mineral intelligence outputs. I'll look at global diamond point of view of mining, but from the point of view of, well, maybe what does it tell us about the places that we are interested in exploring in? And then I'll finish off by looking at the diamond exploration outlook. But just a bit of a disclaimer. Obviously, the conclusions at the end will be probably a bit subjective. I've tried to avoid personal prejudices wherever possible. But given the experience that I've had in the last 40 odd years, that's pretty well almost impossible, I would guess. But we can discuss that after the presentation, hopefully. Let's see where we go. Okay, global exploration budgets. This is the picture that I picked out of S&P Global's Mineral Intelligence Report that was published in April 2022. So it's really hot off the press. Now they describe exploration budgets for the change from 20 to 2021. So I'm not exactly sure if this is a budget or an actual expenditure, but they have data going back to 1997. So let's take it as meaning what is spent or what is being intended to be spent. On the left-hand side, this is a waterfall chart. For those not familiar, it shows the change from one year to another. And on the left-hand side, we have a budget, all commodities exploration budget of just over $8.3 billion for 2020. And on the right-hand side is the budget just under $11.3 billion for 2021. So that's quite a big change over that period. And the green bars and the red bars show the individual changes for the commodities listed on the bottom of the graph. It's, it's quite clear that diamonds is the only commodity that has got less money this year, or 2021, than it had the previous year. And we'll explore that now. Okay, so again, looking at the overall all commodity budgets, the top bar chart shows the trend of global exploration budgets from 1997 all the way through to 2021. The global peak was in 2012. You can see there about $20 billion. So that's already almost double what we are at the moment. And then there was a big dip after 2012 down to about 2015, rising up again until 2020, when you see a dip again because of the global pandemic. But it's luckily picked up again in 2021. Then moving down to the middle, you can see the circular, the middle left shows the breakdown of that $11.3 billion by mine site, grassroots, and late stage and feasibility. The grassroots and late stage feasibility really covers the sort of field of exploration that we would be involved in. But there is some overlap on late stage and feasibility with mine site, and it always depends on who fills in the form and that they give to the SNP. So you see that there's always a bit of muddying of the water in that particular area. The grassroots is fairly clear, and it's only something like 20, and it's a small, I think it's about 26% of the total budget to grassroots. That's the discovery process. That's really what we would understand as real exploration. And then late stage and feasibility, dealing with bringing a project to account, feasibility, preliminary economic assessment, pre-feasibility study, feasibility study, the sort of things that Herman was now talking about that he did for Chidliak. And then mine site is mainly brownfields work done on existing properties, whereby people are maybe trying to extend the life of the existing mine, and just under 40% of that $11.2 billion is going into that type of activity. And then next to that is the breakdown of who is spending the money. So 50% is being spent by the majors. And it's interesting that 37% of that money, according to S&P, is being spent by juniors, $4.1 billion. Just note that number for future reference. Gold and copper are the most targeted commodities. Then here on the right-hand side, what we see is a chart of exploration-related financings for junior and intermediate companies. You see an increasing trend. It's a quarterly graph, so that's why it's not yearly. It's running from every quarter through 2014 to 2021. And in last year, total funds raised by junior and intermediate companies was $21.55 billion. And of that, $4.1 billion is committed by juniors for exploration budgets in 2021. So you see it at 61% year-on-year increase on 2020. And just under 2,000 companies are actively exploring in 2021 and responded to the S&P surveys on which all this data is based. Now, moving on to diamond exploration. This is the sad story of diamond exploration. And there we see on the left-hand side the top table, 2021 diamond budgets. Total amount is 201.5 million, not billion, million US dollars. And the number of companies that report being involved in diamond exploration to S&P 2021 is only 34. So that's 34 out of almost 2,000 companies. And some of those are majors. Some of that 34 are majors. So the number of juniors is even less. On the chart below, you see a breakdown of diamond exploration expenditure all the way from 97 to 2021. In 1997, just over $200 million. And what we're spending in 2021 is actually less than was being spent on diamonds in 1997, and considerably less than the almost $1 billion that was spent in 2007 when diamond exploration was at its peak, just before the global financial crisis. So you had the inevitable drop down in 2009, up to another small peak in 2012, and then dropping down again to the current stage. There virtually hasn't been more than a 2 or 3% increase every year in any given year for the last 3 to 4 years. On the right-hand side, just for reference, top table, you can compare the budgets for the different categories of exploration for all commodities versus diamonds. And then below on the chart, you can see a chart of the all commodities budget versus, in red, what is being spent on diamonds. It's a minuscule amount. So who's spending it and where in 2021? The table on the left-hand side shows we've got 3 majors, Alrosa, Rio Tinto, and De Beers. And notice the next one down, SM Katoka. That's a Katoka company in which Alrosa also has an interest. So you can add that as additional expenditure in Angola. And then I've just listed a few of the other companies that are reasonably well known and of interest that are also spending money. And then there's a batch of others that will be spending just under $3 million of the 200, which is less than 1.5% of the $200 million. So something like 80 odd percent of the actual budget is being spent by the majors. And in terms of grassroots exploration, I don't have the total there. Total diamond exploration is 1.8% of the $11 billion committed, and only a third of it is spent of the diamond budget is spent on grassroots exploration, with something like 88% of it being spent by the majors. So very little happening on that side from the junior side. And on the right-hand side, you see the country spend for the different places. Alrosa, spends over $100 million a year on early and late stage, and that doesn't include their mine site exploration, which is quoted separately. And then Canada and Angola, there's a reasonable amount going into there. Most of the Angolan expenditure is going into Liashi, I believe, although no detail was provided. So I think the big takeaway from this is that when you compare the number of companies overall that are involved in diamonds compared to the rest of the world and other commodities, so a very small number of companies involved. The proportion of budget has always been reasonably small, but at one time, 2003, when diamonds were at their peak, it was actually 14% of the total budget. So there's been a huge reduction over the years. And just to touch on something that Mike David brought up in his presentation as well, diamonds haven't got a bad name because they're doing worse than other commodities in terms of discovery. On the left-hand side, those are the trends for gold and copper, respectively. And they're spending more and more money and finding less and less, but they're still getting plenty of money. Like for gold, over $10 billion in 2021. And I threw in the picture on the right-hand side just to show where that money is going to in terms of the regions. Okay, moving on to actual diamond exploration and what we are involved in and looking at. We've heard a lot about cratons and diamonds over the last couple of weeks. And Herman did a great job of explaining what we learned from kimberlitic indicator mineral chemistry and how important a tool that is. And the new kimberlite discoveries in the last 50 years, where kimberlites and diamonds weren't previously known, has expanded our understanding of the Earth's lithosphere to a tremendous extent. But we can only learn that by finding new kimberlites, lamprites, and whatever else brings these indicator minerals up to the surface. So you have to find them first before you can actually do anything. It's a bit of a chicken and egg type of situation. So to get a view on the potential of the underlying the lithosphere below these cratons, you need information by finding these new kimberlites through exploration, perhaps using the various technologies that we've heard about previously. So today, I think most cratonic regions are reasonably well defined in general outline now, compared to when Tom Clifford wrote his paper in 1966. And this is one of the figures taken from that paper then, which just shows how he defined cratonic areas in Africa and identified the association of diamonds, gold, platinum. He also had figures for other minerals as well, but this one deals only with diamonds, golds, and platinum, and the oldest cratonic areas in Africa. And he identified orogenic belts younger than 1,200 million years between the cratons, and cratonic areas older than 1,500 million years. Of course, now, in terms of greater detail on each of these cratons, the information that we've gathered over the last 50 years has given us the opportunity to find better looking at other areas than the ones he's identified. So there always has been this story about, well, what is the best craton? And then in the early 1980s, Bram Janse brought out a paper detailing this, and this was just after the discovery of the lamproid occurrences, diamondiferous lamproid occurrences in Australia in the late 1970s, where you had lamproids that weren't kimberlites, and you were finding diamonds reputedly on non-cratonic areas, like Ellendale in the Halls Creek zone. Since then, I think the feeling is that these are possibly marginal to cratons or whatever, but that's the way it was. And Bram, bless his heart, gave us this diagram explaining the giving descriptions for these different parts of cratons. The purple are areas over 2.5 billion years old. The green areas were what he called protons, between, I think, 1,500 and 2,500, and then surrounding it, tectons, everything younger than 1,500. You'll find that in the literature, but it's not given much attention these days, I don't think. And people tend to talk broadly still about cratons, but then add in the relevant age information when they're discussing it. Now, the relationship that's been mentioned is Clifford's rule, which implies that diamondiferous kimberlites erupted through the oldest Archean portions of the cratons, whereas non-diamondiferous kimberlites erupted through younger rocks. Now, even though this paper was published in 1966, already in Russia in the 1930s, Vladimir Sobolev, who was Nick Sobolev's father, had published a paper on the geological similarities between South Africa and Siberia. And that triggered the diamond exploration after the Second World War that led to the fantastic discoveries in Yakutia at that time. Also, the research work that Tom Clifford was doing was funded by Anglo-American in South Africa via the Research Institute for Africa Geology at the University of Leeds. And other people and explorers were also interested in this. And that's where Bram's map actually comes from, because all these ideas led to the exploration in northern Australia and elsewhere, looking for new kimberlites and diamond sources, and led to the discovery of the Australian lamproite deposits. So here we are now. We're now in 2021. We know a lot more about cratons than we did in 1996. And a lot of exploration has been carried out in most parts of the world. So what is that going to mean going forward? So when we look at the world in 1960, diamond world in 1966 compared to 2022, there's a huge difference. The lamproites in Australia, the new deposits in Canada, new deposits in northwestern Europe on the East European platform, and quite a lot of new deposits in Botswana and also in South Africa and elsewhere. So there's been a tremendous amount of exploration success. So do we think that means that everything significant has been found? And it was quite interesting listening to Pat yesterday, because he used a definition of, if I remember, if I wrote it down correctly, $2 billion worth of diamonds produced to be a significant mine. Well, you can argue about what number is appropriate, but there have been quite a few of those that have been found in the last few years. And the evidence that we see now in Angola shows that, well, to everyone's surprise, that there is another one, regardless of what people thought maybe 5 years ago or whatever. So there is life still in the old dog in terms of exploration potential in this world. And, is it still worthwhile continuing with exploration to try and find more of these things? But remember that the term significant will mean one thing to a major like a Rio or a De Beers or an Alrosa, but something different to a smaller outfit or organization. Very important to remember that. Now, this next slide is also a courtesy of Bram Jansen, with some modifications by me on the right-hand side. Bram published this in 2007, and it shows the global diamond production history from 1870 all the way through to 2005. And then I've used the Kimberley process statistics since then, up until 2020, because there are no 2021 numbers yet, to tack it on to the end there. And sorry about the cartoon nature of it, but I didn't have any access to Bram's data. And the data sources are given in the references at the bottom of the slide. So what Mike DeWitt also showed a similar chart in his talk, but I'm not going to go into the detail of how he described all the different producers. But what this chart really shows is just the three main phases of diamond production that we've seen over the last 150 years. First of all, the period up until the middle of the First World War, South African kimberlite producers. That's where De Beers was virtually the only game in town. And then between the First World War and up until 1970 was really the period when the large African placer producers were dominant in the global market. And then, starting in the 1950s with the discovery of the Russian kimberlite deposits, and all the way through to that peak that we see in 2005, is the period where the global primary rock producers, and I have to say primary rock because you've got kimberlites and lamproites, have come to the fore. And you can see an absolute explosion, even though some of the discoveries were made in the 1950s and 60s, the real explosion in production started taking off in the 1980s, about the same time that Argyle started coming into production. So the peak there is at 177 million carats, and then it started declining and then hit the global financial crisis in about 2008, 2009, recovered slightly thereafter, and then hit a new peak around 150 million carats I think it's in 2017 up here, and then it's been falling since then, and then took a plunge again with the global pandemic. And we've already seen there's a bit of a pickup, but I think people are starting to realize, and we had, I think maybe it was Lyndon that mentioned it, it's easier to continue than it is to start again once things have been shut down. And certainly in 2021, I looked at the Alrosa numbers, and they're only up compared to 2021 by 2 or 3 million carats. So it is a bit more difficult to pick up the pace again, but I'm sure it will increase further down the line. So the question then is, well, have we already achieved peak diamonds? Are we not going to see 177 million carats a day, a year anymore? You know, that's certainly something that you know, Paul Zimnisky was querying when he gave his presentation right at the beginning of this course. Moving on to just the data that I've been using is for the recent stuff is Kimberley process statistics. This is a picture in 2022. World production of 107 million carats, more or less, from 24 countries. Not all listed there because there's no sense in that. Generating $9.23 billion in revenue, and the average price, so surprisingly low, $86. And I think you can see who the main producers are. Russia is still the standout in carats, despite reducing its output far more than any of the other individual producers. And I've combined West African countries into one group, otherwise you won't be able to see them, and all the others are in the other bucket. So 5 countries produced more than 10 million carats in 2020 each. Russia produced 46% more than the next highest producer, Botswana. 4 countries produced 1 million carats each, and those 9 countries make up 90% of the total carats mined in 2020. It's a staggering idea. The picture changes when you look at revenue, however. Botswana is marginally up in front, but Russia and Botswana, between the two of them, they account for 52% of total revenue. That's 52% from only 2 producing countries. And when you add in Angola, Canada, Namibia, and South Africa, those 6 countries are responsible for slightly over 90% of the total global revenue. That means there's $1 billion distributed between the other 18. We've heard in previous presentations, Alrosa and partners have got this large new kimberlite in Angola, which they're hoping to bring into production shortly. And I'm sure that will help to make up the carat shortfall caused by Argyle closing in the last year or so. That closure reduces the top carat producers to 4, but Angola will join obviously once Luashi comes into production. And it's an interesting situation to be in now, where, you know, I'm used to the idea of people saying, well, you know, hearing about people saying, what are we going to do with all these diamonds? And now we're hearing, where are we going to get more diamonds? And that's a question that I'll discuss later in the talk when we look at the likelihood of exploration finding new major deposits in the short to medium term. We don't think and don't worry that the world is going to run out of diamonds. That's not the case. Between them, Alrosa and De Beers have got over 1 billion carats in proven and proved and or whatever probable reserves, and 1.4 billion carats in resources, according to their official statements. Okay, so for this presentation, I thought, you know, why we're always looking at countries, we're geologists, maybe let's look at how the breakdown by cratons. So what I've done here is this is what this represents, and what you see presented is the breakdown of percent carats for each of these individual cratons. The this I've described as the Kalahari, combining Katval, Limpopo Belt, and Zimbabwe. It's more convenient. Kasai is Angola and the DRC, and I've split Russia into Yakutia and East European platform. And I've also been able to split the Canadian production as well. And it's quite an eye-opener, again, because you see, surprisingly, the Kalahari is out in front, followed by Yakutia, and then the Kasai. And then when you look at the revenue picture, it's quite astounding. I hadn't expected to see this, that the Kalahari produces almost 50%, in 2020, produced almost 50% of the world's diamonds in revenue. And Yakutia is only about 20% and only 5% from the European platform. And look at Argyle, only responsible for 1% of the revenue, whereas the Slave is just under 10%. So that got me just thinking about how to look at this a bit differently. And then I plotted dollars against carats, and it's expressed as a percentage here. And then you can just see on the right-hand side, the Kalahari way out on its own, followed up by Yakutia, and then Kasai, Slave, and all the others. And all the other tiny producers, starting with West Africa, are over there close to the origin. They hardly show on the chart. Now you can do what you like with this. You can split up the Kasai into Angola and DRC. That's possible, and you can do it for individual producers as well. But obviously, I haven't done it. It's too much detail for this particular presentation. But what it does show is, remember, Herb Helmstedt made the statement. Cratons are not created equal. Well, that shows it in terms of diamond content, the Kalahari is head and shoulders above the others. But what about the history? What about the total picture? So I threw together all the data from Graham's paper and the Kimberley process, and I did the same for the period 1870 to 2020. And again, the Kalahari just completely sticks up head and shoulders above the others. Pat said yesterday it's difficult to work out what revenue to use. So what I've done is, to be consistent, I've got total carat production just multiplied by the most recent reliable dollar per carat numbers out of the Kimberley process. I didn't use 2020 because they're depressed, but I used an average between 2014 and 2016 when the last diamond price peak was on the go. And again, what's surprising is the Kasai's got more carats than Yakutia, but it's not surprising Yakutia has got higher revenue. And the Kasai is where it is because of the impact of the Mbuji-Mayi production from the Congo. So if you split up Angola and the DRC, you may see a different picture. And there on the left-hand side, West Africa and the Slave, more or less equivalent. So it was quite interesting. So if we're looking, if there is this belief that the world needs, it's used to getting 150 million carats, and it's only getting 110, where are the other diamonds going to come from? So mining companies have got various choices. They can expand production from existing operations, by increasing plant throughput or bringing unexploited resources on the property into production, but then you deplete your resources and reserves faster. So it's a short-term gain for a long-term loss. You can buy mines or projects owned by others, but it's not a net gain either because somebody's already found something or has something, so you're just swapping your marbles, that's all. Or you can find new mines through exploration. And that's where we come in. That long-term view is needed, but there's not going to be any quick fixes here. It takes time to discover, time, as Herman explained, time for feasibility and development. You can perhaps speed things up by partnering with other explorers and mining companies, JVs or whatever. But one thing you got to get used to in exploration is that success doesn't come every day, and you've got to be able to cope with disappointment and stay positive and be prepared to get on with things the next day. So I put this together just from trolling through the internet on the various sites looking for diamond projects that are on the go, and just a bit of explanation about the what we're calling the development pipeline here. Pat showed it yesterday in a mining context. This is more related to exploration. And here on the left-hand side, you've got exploration comprising discovery and mineral resource evaluation, and then projects and feasibility study. And that's any class of feasibility study from PFS all the way through to near development work. And then project development, mine construction and ramp up. And we're not saying anything about mining today. So here we have all the projects that are under development at the moment. The green is greenfields. Those are based on new discoveries. Not necessarily new. Some, like Star, has been around for a long time, but it's still greenfields. Lomonosov has been around for a while, but parts of it, it was originally greenfields. And Luele is definitely greenfields, and then you've got Mir, Merlin, Juaneng, Venetia Underground, all of those are brownfields. Now the brownfields will only replace old production. It's not something new. All the green ones are something new. But there's only Luele at the moment that really looks as though it has the makings of a big new production. Then on the left-hand side, Herman described what was happening at Lulu. There may be something comes out of that. We still have to see. And in my research, I picked up Metalex Ventures in Canada. I was looking at, they claim to have a 10-hectare target in not far from Attawapiskat in Canada, close to Victor. And then there's also a project subject of a preliminary economic assessment in Finland at this place, which I'm not going to try to pronounce. So the business of exploration, in my view, for any mining company that's serious about diamond mining, exploration is an existential business process imperative. You have to do it. And Orosa has certainly bought into that. They are spending $100 million a year. A lot of it in Russia, I agree, but they've now broken out into Africa, into Angola, and to Zimbabwe. So for major diamond companies, it's about adding new reserves, maintain long-term business continuity. For major multi-commodity companies, sometimes they care less. It's nice to add new reserves, but that will only for them maintain divisional business continuity. And we've seen that with BHP, where they dip in and out of things, and they've now pretty well got out of the diamond business, despite being involved in it for 20 odd years. Then medium scale companies, they can't afford to spend a lot of money on exploration, but they need to be involved in something as part of their business development process, even if it's just reassessing existing deposits or adding to existing reserves by working with other people or whatever. And then junior companies, they're more entrepreneurial and opportunistic. If they are lucky enough to find something, the game is to advance it to mining, if at all possible, and then sell on at least part of it, if not all of it. And we've seen a lot of that happening in Canada in the last couple of years. So the big question, hasn't everything been found? And it's an old question that's periodically asked. I mean, I've been in diamond exploration for 40 odd years now. And there's always this perception that the best have all been found. And aren't diamonds difficult to find? Pat said yesterday, yeah, they are relatively easy to find, but it depends on where you are. It's maybe not difficult if you're in the right places, and the right places behave like they should do, and you do the right things. It's still not that easy. So where do we go? We'll look at the future opportunities, the sort of things that we think about On the left-hand side, primary targeting. Now, these days, again, remembering cratons are not created equal. And a good thing to remember is nor are kimberlites and lamproites. So finding a kimberlite or lamproite is not the end of the game. That just gets you the starting ticket to perhaps finding something that is worthwhile or not. For me, cratons, in terms of where we think about it, have a deemed inherent prospectivity based on things that we have listed there: basement age, the intensity of kimberlite intrusion, ordered diamonds, and everything that goes with it. And then on the right-hand side, if we're involved in exploration today, what I'm calling secondary targeting, what's the amount of and type of work undertaken in the past? Because there are no virgin cratons left in terms of exploration, except on Antarctica. And there are already kimberlites there, we know that. Then you consider cover sequences, the geomorphology and terrain, very important, the weathering, erosional history, and the types of erosion, because that will determine the methodologies you used and how you interpret your results. And then exploration methodologies, what I call direct will be indicator sampling, indirect will be geophysics and other things. And then just to complicate things further, you need to organize your access, and you've got to think about physical access as well as legal access. And the legal access is sometimes even more difficult than the geology. Let me tell you about that. Okay, so we look at, regardless of where you are, what you're planning to do in the future, any new investigation will start with the search for diamonds and or kimberlitic indicator minerals. Remember, in the distant past, all of the major early finds in Kimberley, and certainly all the placer deposits, were found through direct detection of diamonds. But the two quotes I've put on there, and I'm not going to read them out, they come out of, the top one comes out of Brian Janss's paper, and he describes how it's reported in 1869 that the old prospectors had already identified the association between red garnets and diamonds. And then the second quote is out of Wagner's book in 1914, where he describes how the premier kimberlite, the Cullinan kimberlite, was found in the early 1900s. Well worth a read. So the indicator minerals, the traditional ones are pyrite garnet and ilmenite, certainly in Africa. And then when you're close to source, chrome diopside. Southern Africa, you can find the full suite. But in Central Africa, where you're dealing with tropical weathering, where garnet doesn't survive as well in soil and weathering profiles, ilmenite is the preferred indicator. And then out of Australia came chrome spinel later. And of course, in the Arctic regions, like in Yakutia and in Canada, you get the full suite of indicators, and you can use olivine to help direct things as well. So moving on to some of the areas that I'm going to discuss. I know that Yakutia isn't accessible to us, but we haven't really spoken about it this week at all. And apart from the mining yesterday with Pat, so I thought I should at least look through it and look at what, give you a bit of insight as to what Alros are doing. The left-hand side is a geological map published in 1978. It's available online. It's fantastic detail. It's an incredible map, and I've given two close-ups on the right-hand side of areas around Udachny and Murni, respectively. So Pat described the mining areas in Yakutia yesterday. I'm not going to deal with those in details, but this is what Alrosa would describe as their open areas where kimberlites are exposed at surface. And this is the area of mainly Cambrian sediments. And around it is the basin of other sediments of Ordovician, Devonian, Triassic age, and also Jurassic down here, this dark blue. And what this shows is that many of the kimberlites that Alrosa has found actually lie under not only sedimentary cover, but even basalt cover, Triassic basalts. This is up in the north in McKechnie, and taken out of these little dots here that you see are actual kimberlite pipes. This is the McKechnie field here, and it lies in the exposed area. And this is the Icol field with Icol and Jubilee. And you can see they are already in this sort of greenish blue is the Thermo-Triassic basalts. This orange is Permian sediments, and these are the basalts. So some of these pipes were already were covered and were found through prospecting in that covered terrain. And then down in the south, this is Murney. Google Translate is fantastic. You can work out exactly what's going on this map. And then here you have the Mir pipe, and these ones here are International, Sputnik, and some of the others. And they were actually under relatively shallow cover. So tremendous exploration success, and you have to take your hat off to Alrosa in terms of what they were managed to achieve. And out of one of Alrosa's reports, I found this, where they have this chart where they say that the discovery of new kimberlites is much more challenging now, and it shows here the change with time. And then the discoveries made in the 1990s are being found under 70 and 80 meters of cover. This is the New Urba field, which is shown here on the right-hand side. Sorry, my diamond has slipped down a bit. It's actually sitting here. And it was found under 70 to 80 meters of Jurassic cover. Now, there are placer deposits. They describe placer deposits around the pipes. So I suspect that there may have been some leakage of indicators out of the unconformity, but I don't know that for sure. And then this picture is some of the diamonds that I was shown in 1999 when I was in Yakutia. And these come from the Botubinskaya kimberlite that I'll show you now. I took this off of Google Earth. This is the New Urba kimberlite, which is the first one discovered, and then Botubinskaya, which now recently come into production just in the last few years. They're small, but tremendously rich, and they have a reasonably high diamond value. So you get a fantastic $ per ton mine value, and they have placers. They have what they call the Maiskoi deposit or dike down here. Seems to have a reasonable tonnage, so they're looking to mine that as well. That's not why I've put this picture up. What you see here is how they've been going about their exploration. You see this grid pattern here. These are geophysical and drill lines, and these distances here are how far some of these lines go in the various directions of the compass. And then when they got a sniff, they fill in with more and more detailed geophysics and drilling in order to find these things. And they have other deposits that they have found that they're currently evaluating according to the reports, but there isn't any information provided about them. Okay, we discussed Alrosa diamond dollar per carat values. The dollar per carat value shown in the Kimberley process for Russia seems slightly depressed. And one of the reasons for it, if you look here, they produce diamonds down below 1.5 millimeters. Most other producers produced a bottom cutoff of 1.5 millimeters, whereas Alrosa, 30% of their carat production is below 1.5 millimeters. Although it's only that 30% is only 3% of the value. So the net effect is a 30% depression of the average diamond price if you were expressing it as at a 1.5 millimeter cutoff. It's not that simple, but it gives you a ballpark idea. And then also on the right-hand side, this is in the most recent report from Alrosa, shows the change in carat output. These will be million carats for these things. And then these are the individual dollar per carat values for each of these different deposits. And you see this one, the dike 107, look at international, $172 a carat. And it's running at something ridiculous in excess of 5 carats per ton. I think Pat said yesterday 8 carats per ton. Anyway, I suggest if you want to look, go and troll the Alrosa website. It's well worth looking at. So moving over to Western Russia, it's always difficult. They talk about the Northeast European platform, but it's a lot of it is in Western Russia. So it's the most recent new development in production area post breakup of the Soviet Union. And it's really been opened up, I think, because of loss of control by Alrosa during the 1990s when all those changes were taking place. Alrosa had actually made these discoveries initially in the 1960s and drilled them out in the 1980s and did the bulk sampling then, but nothing happened until the early 2000s. And the two producing mines, the AGD's Grib pipe, which is independent of Alrosa, and Alrosa is working these other two. And this is where they are, close to the city of Arkhangelsk. And these are the Lomonosov deposits, the Grib Verkhotina field here. These are only two fields that have got economic deposits in them, but there are a lot more kimberlites around there that Alrosa say, well, the commentators say are uneconomic. And the whole area is covered by something like 50 meters of Devonian sediments, which is older than the age of the kimberlites in that area, which is why I've put in this picture. And that's a picture of one of the mines being developed. Now, this whole area has been the subject of intense legal dispute for at least 10, 15 years, up until about 2010, through 2010 to 2012. And it's only since then, for instance, the Grib deposit has started to be developed. So there's virtually been no new exploration done in this area since the 1990s. So I would expect that this area is still highly potentially prospective for new deposits as well. Okay, we're going to move on to Australia. And some of you might wonder, well, why Australia? Well, because it's interesting, because it doesn't fit the book. It doesn't fit the standard book. It has a long history of diamonds, 1851 in New South Wales alluvials here, early 1900s, a diamond found at Nullagine, but nothing much went on until the 1960s and 70s when everyone was getting into diamond exploration again all over the world. I'm not going to describe the detail of the Ellendale and Argyll discoveries, but they were made, as we all know. And then that really set off a lot of diamond exploration throughout Australia, and De Beers was part of that as well. It's not as if there are no cratonic blocks. There are plenty of big cratonic areas there, but exploration in Australia has been extraordinarily unsuccessful, apart from Argyll and Ellendale and Merlin, which in the last two, didn't last very long in terms of mining output. So Argyll was really the big find. And I guess the important takeaway from Australia is that it's much of the country lies under an intense weathering profile from the Cretaceous time. Got extreme weathering, lateritic weathering, and indicator minerals were being destroyed. Added to that, very few of the kimberlites in Australia have ilmenites, so ilmenites wouldn't help. Garnets were getting destroyed in the soil profiles, and spinel and diamond became the only indicator mineral. And it wasn't very widely disseminated that Argyll was actually found on diamond counts in stream samples, not on spinel, which is the normal sort of story. But Argyll was found on diamonds. So I've just to run through this quickly. These are the sort of soil profiles. This is in the left-hand side in the Kimberleys. Looks like a normal soil profile. I'll show you some similar ones from South Africa. And then on the right-hand side, this is up north in the Kimberleys, 1 to 2 meters of ferruginous soil overlying the kimberlite, highly kaolinized. But on top of the kimberlite, you can find spinels and what have you. But 10, 15 kilometers away, you will find virtually nothing. It's very difficult to find these things. And then on the Pilbara and the Yilgarn, a lot of prospecting was put into those cratonic areas over a very long period of time. A lot of money spent, and nothing was found, despite Nullagine, until the late 1990s, when all of a sudden De Beers found the Brockman dike on the Pilbara. And it's not as if this thing, was hidden. It was there in plain sight. That's it. It's outcropping. And there it is running for something like 20 kilometers into the distance. You can see it in the top there. It's incredible. Very low microdiamond counts found on Spinel anomalies. When you were right on top of the dike, you could find a garnet, and this is what it looks like actually in the field. Macrocoustic olivine, all obviously pseudomorphed, but very interesting deposit, although no economics. So having found that, you could pretty well say, well, maybe all the work that was done in the past in Australia did show that there was nothing significant on the Pilbara. Similar thing in the Yilgarn, and this shows the examples of these thicker lateritic weathering profiles on the granites in the eastern goldfields. But as you move further westwards, these things are eroded. And what this whole area here is the underlying peneplain that is exposed once the overlying duricrust is removed. And once you do that, if there's a kimberlite, you can reduce the kimberlitic indicator minerals. And this is surface float over a kimberlite that was found on the Yilgarn, just these lumps of kimberlite. Again, a dike or a sill, we didn't do too much drilling on it, but it is whatever it is. But these bits of kimberlite were just lying around, and you can see the textures all silicified. And this is it actually on outcrop. So again, these things were found just on the basis of Spinel indicator mineral sampling, nothing else at all. And the fact that Australia is different because of the types of the mineralogy of many of these deposits makes it a very difficult environment to explore and to walk away from. So moving on to the Kalahari Craton, we've discussed that. I counted up the number of mines, and there's something like almost 47% of the world's major diamond mines lie on the Kalahari Craton when you put the numbers together. And I think that shows in the diamond production, and we've discussed that a lot this week. I'm not going to go into the detail of the Craton, but in terms of this is where I've spent most of my career, certainly in terms of my early exploration days. And I'm pretty satisfied that the bulk of the Kalahari Craton has been explored to the extent that you can safely say there's no more very significant deposits to be found. It's quite possible that there may be one or two small things still sitting around, perhaps on the covered areas in the Kalahari Desert in Botswana. But then remember, north of Jwaneng, you run into the Karoo as well. So the area between Jwaneng and Orapa is only prospective for Cretaceous age kimberlites. There's maybe some potential, it's still in some residual potential in parts of Zimbabwe because of the lesser amount of work that's actually been done. But some of the Zimbabwe kimberlites are outcropping, and they've also got funny signatures like we see in Australia, where you don't easily find the full suite of indicator minerals, but some of them have only got spinels. But for the Karp Val itself, and I'm using Karp Val as opposed to Kalahari, the main Karp Val, as you'll see in some of the pictures, the soils are thin. This is where Pat is quite right. If you're in the right place, you're doing the right thing, you will find kimberlites. And this is some examples, soil profiles anomaly. This is the Western Bushveld, thin soil, maybe 1 to 1.5 meters and straight into weathered bedrock. This is a kimberlite dike in Lesotho, very thin soil, not even, maybe less than a meter. And this is a typical garnet soil anomaly over a kimberlite dike running this way. and this is what you find on top of it. This is at follow-up, and these are the indicator counts that you get from fairly small samples. And this would have been found, this is a very flat area, just like this, and this would have been found on the basis of indicator minerals being dispersed downwards by this very low flat line drainage. Just something different. This relates to the Dahlstrom dikes, and what's interesting about this photograph here is that this dike also lies under a lateritic weathering profile, and this is an ancient land surface. Probably it's not dated, but it's been highly weathered and ferruginized. You've got ferrocrete material here. And in the soil profile, you can't find any indicator minerals right above the kimberlite. It's only once you go deep 2-3 meters down that you find the actual kimberlite, and that's where it was dug out. This is 2 kilometers to the east, where there is no lateritic weathering profile, and you find the kimberlite on the basis of normal kimberlitic mineral sampling. You couldn't do that here. This was found by extension from elsewhere and drilling through the cover. And this just shows what the kimberlite looks like at this sort of depth. You can still see, you can see the kimberlite texture. It's quite clear what it is. A couple of other examples, kimberlite profiles. This is over palmite kimberlite, lumps of basalt there, and you can see lumps of basalt retained in the overlying soil profile. It's also about a meter thick. That's Jan Stiefenhofer when we were up there. An outcropping kimberlite in Zimbabwe. It's interesting that most of the outcropping kimberlites that I've seen in Southern Africa have been either in the Limpopo belt or in Zimbabwe. And on this side, we see this is the soil profile over Marsfontein in the northern Transvaal. Sorry about the picture. I didn't take them, but tried to put them together. But this is a zone of super enrichment, and from in this area, the grade was running at something like 14 carats per ton at $200 a carat. It was just incredible. And this is just an area where, even though it was a small pipe, you had this near surface enrichment over the top of the kimberlite. Always something to look out for. So moving over to the Kasai, I'm conscious I'm over time. I'm only going to talk about Northeast Angola because that's what I regard as prospective, and I'm not going to touch on the Congo side of the border. Here we have a map of Southern Africa with the area in Northeast Angola outlined in yellow. This is an old map from that I picked up on the internet. It just shows the non-kimberlites that were found, that have been found in the valleys running north-south into the Congo. I should just point out this is the Kalahari basin, which extends into northern Angola, and all these interfluve areas here are covered by Kalahari and Kalonda sediments. And the kimberlites that were discovered in the 60s and early 70s in Angola all tended to be in these valley areas. So De Beers went back, and they were there in the 1990s and early 2000s. And this picture is of kimberlite found underneath the Kalahari and one of those interfluves. So about, as you can see there, it's over 150 meters of material. And De Beers reported that these things are sub-economic and nothing could be done with them. So I took this off Google Earth as well. This is a profile running from Lukapa in the east to Kafunfu in the Kwango Valley in the west. And this blue line, this very vague blue line here, is the thickness of the Kalahari and Kalonda. Now you can interpolate, maybe it's like this, perhaps there's a bit of high ground here all the way through. And we've seen from Herman's photographs that it looks a lot shallower over in the Kwango Valley. So perhaps there is a bit less, but the level of erosion is probably not that different to the kimberlites over here. So there still may be some disappointment with regard to that solid waste that you find and is typical of Katoka and some of the other kimberlites around Lukapa. Just a last word on Luele. This is what Alrosa described it as, and it's this. Other people are talking about Luashi, probably just to help confusing. The Google Earth image shows the position of this pipe. I think Herman showed this also in one of his presentations, sitting here 20 or 30 kilometers southwest of Katoka, very, very convenient, not too far away. And Alrosa says it's the largest diamond discovery of the past 60 years. And that must put it somewhere between Jwaneng and Arapa. And when you measure this circular feature down here, it just comes out to 60 hectares, more or less. And then they say the resource base is 350 million carats and give the average grade. So out of that, you can work out what the resource tonnage is. And when you do that using an SG of 2.5, I'm assuming they've got an indicated resource to 100 meters over 60 hectares, and initial and the sort of plant throughputs that we were hearing about yesterday would give, for stage 1 of the new production, an initial 3 to 4 million carats per annum. Sorry, I've missed out the million. And over the long term, once it's all built up, 10 to 12 million carats per annum. So this is a significant discovery, and it's probably going to be in the range, I hope, of, I would assume, of $100 a carat if it's anything like Katoka. So on to the final slide at last. My prejudiced opinion of the medium-term potential. Kasai's got the best short to medium-term potential. It's as close to virgin craton as you're going to get anywhere because of the very little work that's been done over the last 20, 30 years for political and legal reasons. I would still put Yakutia second. Alrosa is very good at what they do, and they keep turning up new things, and it's highly prospective territory. You have to ask the question, the fact that the Kalahari has got so many more diamonds in Yakutia and Kasai, is that maybe because they just haven't found everything yet, or what? These are areas that are less exposed in the Kalahari Craton, which is why I placed them relatively high in the process. The Slave and Superior and East European platform, I think moderate potential, I would put that. There are guys in Canada doing good work on the Slave and Superior, so let's see what they turn up. It's not impossible that something new can turn up. Breaking down the Kalahari, I've already described that. And I think in South Africa, alluvials and old prospects are really the name of the game going forward. And Northern Australia still has low potential. It's going to be a lot of hard work there if people are prepared to get involved. But maybe, if Merlin comes back into production, depending on the diamond price they get, maybe that will trigger a new phase of exploration there. Thank you very much, and sorry for running over my time.
Thanks, Bill. Drinks are on you, so you better pass them around. That was excellent. Thanks, Bill.
That was the pre-seed version.
Okay, fantastic. And if I heard, I said, drinks on you, so pass it around. Okay, catch your breath or have a drink, and let's open it up to questions. There's a lot of fascinating stuff there. Right, who wants to kick off?
I'll kick off with one or two questions.
Great.
Bill, you haven't said anything about Brazil. So
yeah, I meant to say apologies for that, but I mean, Brazil, the thing about Brazil is it was never difficult to find kimberlites. It was just,
do you want to download, sorry to cut in, just download your or stop sharing, and then we can see people. Okay. No, sorry, thanks.
Sorry, I forgot about that. No, just share it again. It was never difficult to find kimberlites in Brazil, as you know. The problem was finding kimberlites with decent quantities of diamonds. And certainly in the early days when De Beers was working there, they were looking for Orapas and Juanengs and those sorts of things. So, if the initial sampling didn't pass the muster, then they would move on to something new. I think the work that Ken and Paolo and the team are doing over there is fantastic. It will be great if Brauna really, picks up the legs and gets going, and perhaps that will be the spur to further work in Brazil. But over the years, it was pretty disappointing in terms of the outputs.
Another question comes to mind. It might be a bit early to even discuss this, but with the war in the Ukraine and the sanctions against Russia, is there any indication as to how this might affect Alrosa operations and sales and marketing?
Well, I think there's lots of rumors around. I don't have any specific information. I think that the Alrosa is taking the view at the moment that Angola, they're in minority. I'm not sure what the situation is with regard to the new deposit, but that's the case with regard to Katoka, so it should be business as normal. But it's a big problem for the industry, I would guess, if Alrosa is not able to put its production onto the market. And not just a problem for Alrosa. Does anyone else have any other information?
No, Bill, I mean, when you read all the, the goings on and the fact that so much of the stuff is small and goes to India and gets cut, and that kind of makes it exempt from, the embargo. But obviously the embargo is really about, sales, I think, directly into the US. But I think probably the next, as Paul said, it'll be the next half of the year that will really, show what the real challenges might be. And if I can kick off while we wait for other questions, I mean, so much of this bill also goes back to understanding, I guess, geomorphology, particularly obviously in this country and in the Kasai. And then, equally, I guess it's a similar thing, but somewhat different in terms of ages. And there's a lot of potential, I guess, in buried kimberlites, in covered kimberlites in Russia or the Siberian Kraton.
Yes, absolutely. It'll be slow and it'll take a long time, but Alrosa has got the reserves the next 20 to 30 years, so time is on their side, and they have a monopoly there, and they're finding things in other places, like in Angola. So that's going to make a big difference to them as well.
Bill, a question. You mentioned earlier that you saw the potential in South Africa in the alluvial field.
Yeah.
Are you specifically talking at the Middle Orange River, or are you looking more at the offshore version? What is the space for the small digger, the artisanal digger, or is it the professional digger that you see being the future of alluvial diamonds?
I think if you can get the, if the regulatory, there's it's interesting that the alluvials start, around Ventersdorp, Lichtenberg, and move this way. And obviously coming out of Lesotho as well. There's virtually nothing in the northern side. I think I've deliberately left Namaqualand, Alex Core, and the West Coast because that's, I'm not, I don't have detailed knowledge of those areas. I obviously know something about them, but I was looking at the inland areas. But for some time, I've believed, like has been reinforced this week, that there's a lot more, well, these last 2 weeks, there's a lot more alluvial potential, and that our understanding of how these things have developed and where they come from can be improved on. And I hadn't really looked at it until after I retired from Snowdon, just looking at it again and reading some of the work that's been done over the last 10 years or so, particularly. And I've obviously got my own, thoughts and prejudices in terms of, how I've seen the geomorphology of South Africa developing. But I think that's also, something for another day. But the key thing is, anywhere on the Vaal, Orange rivers, is worth looking at carefully. And it's obviously difficult, but, depending on what you can find and what you can get, it could be, medium scale operators, sort of things that Lyndon was describing, and it could be things smaller than that. I don't have recent experience of seeing the small operators in operation.
Thank you.
Yeah,
Pat, I see you on the call. Do you have any thoughts about the development of the alluvial diamond fields with respect to SADPO?
Yeah, obviously, I hope you can hear me. I've been load shedded to death, but I could not follow Bill's presentation. I've just now 5 minutes ago been able to log in again. So, but obviously we are hopeful for the future that with the new information, as Bill describes it, that some more potential alluvial sites might be found. But through SADPO itself, I mean, we in the hands of the experts, and what we're trying to do is make it easy once it's discovered to be able to operate.
Yeah, I think, I would say it's more than potential. I think it's, they're there. It's just a case of finding them and identifying the best areas. I think, based on what we've been discussing the last couple of weeks, there are deposits there. It's just a question of identifying them.
Yeah, but and I think you've hit it on the head. Sorry, Tanya. I mean, it all goes back to the regulatory environment and compliance in this case. And if we had an enabling environment, the work done by Pierre and John Ward and others in the Northwest have shown that those sort of interfluvial or interglacial river deposits are far more extensive than initially thought. And the Middle Orange River and that area has huge potential. The key thing is you want to be able to operate, rapidly and efficiently. So I fully agree. I mean, I'm obviously biased, having been in the business, that there's a lot of upside. It'll never be, hundreds and millions of carats, but it'll certainly be, quality carrots. And the most important thing, and that's what we desperately need, is obviously creating jobs and reviving economies in those small towns.
I think, Bill, if I could make a comment, another factor, if you like, in terms of exploration, is those deposits that have, not all cratons are equal, not all kimberlites are equal, not all diamonds are equal. And those kimberlites that contain exceptional diamonds are particularly difficult to, well, I would say impossible to identify before discovery, and very difficult to evaluate once those kimberlites have been discovered. So that is perhaps a future direction of diamond exploration, to revisit discoveries and test to see if they have those large diamonds.
Yeah, I agree. And I think also, if you think about Victor in Canada, and the diamond's got a different paragenesis, if I understood Herman correctly. And, so can you find areas like that have got potential for a different type of paragenesis that hopefully would tend to be a lot better? You might hit a Victor, you might hit an Argyle. But if it's running at 10 carats a ton and it's an Argyle, it's still okay. But it'd be nice if it was a 10 carat per ton deposit and it was a Victor. The other thing I wanted to say, Argyle closing is going to have a huge impact. It will already change the profile of the industry in terms of, you know, the average dollar per carat of what's reported in the Kimberley process and lots of other things. And all of a sudden, you know, whatever replaces it is going to be much higher quality production, which will be good for the industry overall, I believe.
If I may ask another question in terms of the alluvials and South Africa per se, it's a layman's question and probably has been touched on during the 2 weeks that's passed, but the question remains to me, if you go, we talk about the Middle Orange River and we talk about the Lower Orange River, but there's quite some distance between the two, and the current drainage system of the Orange River obviously might have changed, I don't know, but I do not understand that the diamonds tend to disappear from more or less Groblershoop and then reoccur more towards the Richtersveld. It's just a layman's question.
Yeah, I'm not qualified to answer that one, Gert, sorry.
Yeah, Gert, I mean, it's an important observation. I think as Henny van Wyk showed around the corner from Prieska, you know, there are other deposits in, for example, the section of the Orange River between Prieska and Uppington. You know, obviously not as extensive. And then there's scattered deposits through you know, that area, sort of in what's at Namaqualand or central and eastern Namaqualand, like Hulpits, for example. But those deposits are very much more dispersed, and I think it goes back to geomorphology. It's what Bill and John and Mike DeWitt and others are saying. You know, there are large parts of this country we still need to figure out more carefully the geomorphology, and you know, where those big rivers actually went or where they moved, and you know, where did they leave diamond deposits. We've all been spoilt by the Northwest Province and the Vaal and Orange River, but you know, we need to probably go and look at some of those in between areas between say the Orange and the West Coast, our West Coast, the Namaqualand West Coast. But you know, that again, we need some of these young students to get out there and, you know, go and work those or go and have a look at those areas. But,
yeah, see, John, there's a question in the chat box.
Yeah.
I'm not sure if it's Jean or Jean.
Yeah, John Flamenis, yeah.
Why are the pipes in KZN not diamond bearing? I'm not sure if there are kimberlite pipes in KZN, but if there are, they would be off Kraton, which is why they wouldn't be diamond bearing. I've got a vague recollection of maybe a melnoite or something in KZN.
Yeah, the Ashawi melnoites. Remember that Tony?
That's it. Yeah.
And then again in East Griqualand, I think they're also sort of perhaps the odd kimberlite, but also going melnoitic stuff. You know, I mean, the real reason, Bully, you've said it, is off Kraton.
Yeah.
And you know, that line is very sharp. And it's also quite interesting, you know, if you look at sort of the southeast part of our Kraton, you know, in the southeast and Mpumalanga and parts of northern Natal where you do get a bit of sort of cratonic basement. I mean, you didn't find diamonds or kimberlites until you sort of got to Dokawaya in Swaziland, and then obviously your Dahlstrom dikes that you showed.
Yeah, that's right, John. I mean, Dokawaya was found just before I came to South Africa, but you also remember, you know, a lot of that area was, Zululand at that time, so it wasn't accessible until much later. You know, Tony Robertson did a lot of work up in that area, but I'm not sure how far north he went. And I don't recall that we did too much apart from stream sampling in those areas on the Swaziland border.
Yeah. And then of course, you know, there's the golf club anomalies or the golf green anomalies.
The famous the Colenso golf course, and that's when the ladies they started claiming the diamonds in Ladysmith. I immediately thought that's what it is.
And it was concentrate from where? From Premier, I think.
From Cullinan, yeah. After the end of the Second World War, when they were restarting Cullinan, some bright spark on the mine decided to sell
concentrate tailings
waste rock from the mine and concentrate for road metal and for use on railway lines. And so you get these fantastic anomalies all over the Transvaal and all the way down to Natal on the road to Mozambique as well, and also all the way up to Polokwane. In fact, I've got a picture of a road south, but at Rayton, with a lump of kimberlite in it, with the tar road.
It was the diamonds. It was a Steve Haggerty found diamonds in an old structure somewhere around. Was it the Big Hole or one of the Kimberley mines many years ago? You know, looking around some of those old dumps in an old remnant building, I think there was a diamond sticking out of the wall. Okay. And Mike, just going back to your comment about those very low grade kimberlites with exceptional diamonds. I mean, I think the next target, and I think he might be quietly doing a bit of work on it already, is, you know, how do you develop pathfinder methods or indicator minerals that are going to, you know, delineate or take you to those big exceptional diamonds and very low grade kimberlites. I'm sure Andy Moore is also pondering over it. One of the questions I've had come up from some students, not necessarily on this course, and I've sort of had it in my own career, is the fact that, you know, geology is not an exact science, and it means that you sort of can do lots of things. And certainly, and Herman, maybe it's time for you to come in here. We talked about it the other day, the fact that, you know, diamond geologists end up with a huge number of skills. I mean, as we've seen in this course, you can go everywhere from geophysics to mineral chemistry to diamond studies. And so, you know, very often I think today young students look at, you know, what futures there in geology and what futures there in diamonds. Here we're saying, well, we don't think there are necessarily lots of new discoveries that are going to come up, but I don't think students should be put off by that. Maybe you, Bill, want to comment. You've been in the game a long time, and equally Herman.
Yeah, I mean, in diamond exploration, you never know what's going to happen the next day, type of thing, you know, because, I mean, when I joined De Beers in late 1974, I was told that I would be going to work with Alex Van Zyl for the next 3 to 6 months to help him close the Transvaal operation as it then was. Then I spent 11 years in the field, going from one kimberlite discovery to the next. It was
And-
incredible.
And you're still in the Transvaal.
And I'm still in the Transvaal.
No, it's an incredibly broad field. Herman, do you want to come in there as well?
Yeah, look, yeah, I'll provide comment there, but the host has disabled my video. So if somebody can just enable my video again, then I can share my face as well. Oh, there we go.
It probably happened when my screen was unshared.
So there's my face, but I also want to share my screen quickly.
Been a long 2 weeks.
If you guys can see a piece of core there, this is the kind of thing that makes your hair stand on end. This is a drill core from an Angolan kimberlite. There's a mantle xenolith sitting in the middle there. It's NQ diameter core, so it's quite a small little mantle xenolith. There's a coating of kimberlite magma sitting outside the mantle xenolith. This is what's called a lapillus. It's all extremely well preserved by a carbonate cement infilling over here. And these red pieces are pieces of Karoo siltstone. It's called the Kassange in Angola. But inside this piece of Karoo siltstone, that's a trace fossil. This is a worm burrow that was in the sediment, in the Karoo sediment, as the Karoo sediment was being deposited, and that worm was escaping the sedimentation that was going on, and it's left this trace fossil in here. This particular picture sort of encapsulates why I've been in diamonds all this time. It's the only version of geology where you can think about the mantle, think about magmatism, and at the same time think about sediments and things that are going on in the upper crust, the upper crustal regime. And it's such a broad scale of thinking of geological processes, and the way we get trained as diamond geologists allows us to examine all of these questions all at once. So it's such an interdisciplinary study that I found in my career I'm able to translate into all sorts of other aspects of earth science, simply because I've had this training in the diamond world of being able to think broadly and laterally and on a conceptual level, and then at a very, very detailed scientific level as well. So it's an extremely exciting field to want to get involved in. And the skills that you build up in the diamond industry are eminently transferable. People who do well in the diamond industry do well everywhere else as well. And I've seen that through my career. There are people who have worked with me in the diamond resource delineation and diamond exploration that then subsequently go on to other kinds of engagement with the industry, and they all do well. It's amazing how well trained the cohort of people are that are in the diamond industry, and how unique the industry is from that perspective.
Yeah, fantastic and fascinating.
Yeah.
And a piece of rock out of the middle of Angola says it all.
Yeah, it's incredible. I mean, we also have dinosaur bones out of the crater facies material from, I think it's this exact same kimberlite.
Amazing. And well preserved, Herman.
Yeah, look, this once you get down beyond the laterite horizons, it's as well preserved as kimberlites are on the Cobalt Plateau.
Yeah, and I mean those Kalondo and the Kalahari Basin. I mean, if ever rocks will, or if ever those sequences were looking for an intensive, wide scale geomorphological and sedimentological study. I mean, they're classic examples.
But the reality is this, I started my career with De Beers on the 2nd of February, 1987.
Mm.
I learned all the basics that I needed to know to understand this rock in Angola from doing work in Kimberley, in the Kimberley mines, and in the petrographic unit that we were trained as junior geologists.
Mm.
It was all there. And it's an education that's invaluable, in particular in today's environment. And as I said, the skill set is very transferable.
Yeah, and I think the one thing about it, it takes you, and you've mentioned that you go from intense detail through to having to put together the macro picture.
Yeah,
and work with mining engineers and so on.